In this video, we will learn to solve exponential and radical equations such as these. Now, I am sick, so I apologize in advance for the sound of my voice and the lack of any personality in my voice. So, looking at problem A, it would be very helpful to have like bases. So, there's more than one way to do this, but one way is to recognize that square root is the same thing as the 1/2 power. So looking at it that way, we have 8 to the x minus 2 power is equal to 8 to the 1/2 power. Since the bases are the same, then the exponents will be the same. So we have this, and then we would just add 2 to both sides. So that's going to give us x equals. Now look, we have 1/2 plus 2. You can look at this as 2 over 1. You can make this into like denominators, okay, in this way. So we would have x equals 1/2 plus 4 over 2. So that would be x is equal to 5 over 2. Okay, so that's one way to do it. Another way to do it would be you can get rid of the radical by squaring both sides. So you can look at it as squaring both sides of this. Now, when you do a power to a power, you multiply. So if you look at it this way, then we have to do x minus 2 and times 2. So you're going to wind up doing the distributive property. So you would have 8 to the 2x minus 4 power is equal to 8, alright, because the radical and the 2 would cancel. You could look at this as being the 1 power. Since the bases are the same, the exponents are the same. So this would give you 2x minus 4 is equal to 1. Then you would add 4 to both sides, so that would give you 2x is equal to 5. And then you divide both sides by 2, and you'd have x is equal to 5 over 2. So either way, you're going to get the same answer, so you can decide which one of those two methods made more sense to you. So let's go on to B. So we're going to need like bases. So I've got the 4, and I know that 64 is 4 to the 3rd power. Okay, so looking at base 4, and there's your 64 is 4 to the 3rd power. Okay, so a couple of things. So that means I have 4 to the x plus 1, and this is 1 over 4 to the 3rd power. Now, because this is in the denominator, this would be the same thing as 4 to the negative 3 power. Now, since the bases are the same, the exponents will be the same. So that means x plus 1 would have to equal negative 3. As we subtract 1 from both sides, that's going to give us x equals negative 4. Okay, so that will be the answer. Looking at problem C, it would be a good idea to get the radical by itself first. So I would subtract 4 from both sides first. So that's going to give us the square root of x plus 2 is equal to x minus 4. To make this radical go away, we could square it, but we need to square both sides. So that's going to give us x plus 2. Wait, I said it, but it didn't happen. X minus 4 squared means x minus 4 times x minus 4. Alright, remember to multiply this out, we need to double distribute. So we have to distribute the x. Alright, x times x is x squared, x times negative 4 is negative 4x. And then we need to distribute the negative 4. That's another negative 4x. Negative 4 times negative 4 is positive 16. So that gives us x squared minus 8x, combining like terms, plus 16. Bring this down. Let's get 0 on one side, and then we'll either factor or we'll use the quadratic formula to finish it. So we will subtract x from both sides and subtract 2 from both sides. So that's going to give us 0 equals x squared minus 9x plus 14. This might be factorable. So x squared can factor as x and x. 14 is 2 times 7. If we want a negative 9, both of these would have to be negative. And a negative times negative is a positive. So we can get one solution by setting x minus 2 equal to 0. And we can get another solution by setting the x minus 7 equal to 0. So adding 2 to both sides, we have x equals 2. Adding 7 to both sides, we have x equals 7. Now, when we solve radical equations like this, we will often get extraneous solutions that don't actually work. So let's check each one of these and make sure they actually work. So let's start with the x equals 2. If I were to plug that back in, then that would give me this. I'd have the square root of 2 plus 2 plus 4, and that's supposed to equal 2. Well, this is the square root of 4. So that would be 2 plus 4. But that would be 6. 6 obviously does not equal 2. So that means that this is extraneous. Alright, it just didn't work. So let's try the 7. So that would be the square root of 7 plus 2 plus 4 is equal to 7. So this would be the square root of 9 plus 4. That would be 3 plus 4. So that would be 7. So this one checks out. So x equals 7 is our only answer for C. Okay, let's look at D. Let's isolate the radical part. So let's start by adding 6 to both sides. So that's going to give us 2 fifth root of 8x plus 16 is equal to 4. And now let's divide both sides by 2. So that'll give us the fifth root of 8x plus 16 is equal to 2. Now if I want to get rid of the fifth root, I can do the fifth power to both sides of this. So those will undo each other. So this is going to give me 8x plus 16. 2 to the fifth power is 32. Okay, as you can see here on your chart if you need it. So the rest of this is pretty straightforward. Subtract 16 from both sides. That'll give us 8x is equal to 16. Divide both sides by 8. So you get x equals 2. Alright, you should check this and make sure that it works. Looking at E, I can get rid of this radical by squaring both sides. So that'll give me x squared is equal to 7x plus 8. I need 0 on one side, so I'm going to subtract x, and I will subtract 8 as well. So that's going to give me x squared minus 7x minus 8 is equal to 0. Now let's see if this will factor. X squared would be x times x. 8, 2 times 4, or 1 times 8. Inner I have 1x, outer I have 8x. I'm trying to get negative 7. So if I do negative 8 and positive 1, that would do it. So positive 1, negative 8. That also gives me negative 8 when I multiply, so that's good. Okay, when I set these equal to 0, so like x plus 1 equals 0, x minus 8 equals 0, I will get my two solutions of x equals negative 1, x equals positive 8. Now we definitely have to check and make sure that these actually work in the original equation. I can already see that negative 1 is not going to work. Doesn't make sense. If I try to substitute negative 1 back in, that would give me negative 1 equals the square root of 7 times negative 1 plus 8. You can't take the square root of something and get a negative number. So I can just stop right there. So negative 1 is definitely extraneous, so forget about that. Let's check and make sure 8 works. So if I do 8, then that would give me 8 equals the square root of 7 times 8 plus 8. Okay, let's see. So that would be 56 plus 8. So that's 64, which does equal 8. So that one checks out. So x equals 8 is our only solution. Alright, what about f? Let's get this part by itself first. So we will add 2 to both sides. So that's going to give me 3x plus 4 to the 3 over 2 power is equal to 64. So the way to deal with a fractional power is to do the reciprocal power. So I'm going to raise both sides to the 2/3 power. Now if I do that over here, these are going to cancel out. So that's giving me 3x plus 4 is equal to 64 to the 2/3 power. Now remember, a fractional power is in the form power over root. Okay, so this is really the third root. So this would be the same thing as having the cube root of 64, and then 2 is the power. The cube root of 64 is 4. Alright, cube root of 64 is 4. So this is going to be the same thing as 3x plus 4 is equal to 4 squared. Of course, 4 squared is 16. And then we will continue to solve by subtracting 4 from both sides. So that'll give me 3x is equal to 12. And then I will divide both sides by 3. And that's going to give me x equals 4. Okay, and you should go back and verify that that actually works out. Okay. So these are both fourth roots. So I can make these go away by doing the fourth power on both sides. So that would give me 3x minus 5 is equal to 5x minus 8. So then I would subtract 3x from both sides. So that's going to give me negative 5 is equal to 2x minus 8. So adding 8 on both sides, that's going to give me 3 is equal to 2x. And then I'll divide both sides by 2. So I get x is equal to 3 over 2. We definitely need to check this. If I put 3 over 2 in here, then I've got the fourth root of 3 times 3 over 2 minus 5 is equal to the fourth root of 5 times 3 over 2 minus 8. Well, so this is going to make 9 over 2 minus 5. Right, this is like 5 over 1. I can make like denominators. Okay, so this would be like 10 over 2. Alright, let me just keep doing this side for a second. So 9 over 2 minus 10 over 2 is negative 1 over 2. So I can stop right there. I have a negative number underneath this radical. This is no solution. Okay, this would be an imaginary number or something. So you can't take an even root of a negative number. So this is extraneous, and that was our only solution. Excuse me. So the answer to this one is going to be no solution. So hopefully you can see how important it is to check your answers. Okay, last one. Let's get this part by itself first by subtracting 7 from both sides. So that's going to give us x plus 4 to the 1/3 power is equal to negative 3. Alright, to deal with this 1/3 power, we will raise both sides to the 3 power. We'll do the reciprocal power. So we'll cube both sides. Well, these 3's will cancel out. So that's going to leave us with x plus 4 is equal to negative 27. Alright, if you have a negative odd power, it just stays negative. And then we will subtract 4 from both sides. Alright, and this is going to be negative 31. Alright, you should check and make sure this actually works out. Alright, you know what, I'll show this one. So this would be negative 31 plus 4 to the 1/3 power plus 7, and that's supposed to equal 4. So this would be negative 27 to the 1/3 power. 1/3 power is a cube root, so this is just going to be negative 3 plus 7, and that is in fact 4. So this one's okay.